Since roots can also be represented by rational exponents, I can use a similar strategy when I'm trying to solve something that has a rational or fractional exponent instead of a root. So if we take a look at part A here, I'm going to use the same strategy I used above. Above, we got the root by itself, so here I'm going to get the thing with the rational exponent by itself. That means my first step is to add 4 to both sides. So I get x to the 1/3 power equals 4. And now I want to get this rational exponent to go away. So what I'm going to do is use the power property, the power rule that we have for exponents, to get this exponent to reduce to 1. So remember when we have the power rule, when I have a power to an exponent, we simplify that by multiplying those powers together. So what I want is to be able to multiply two numbers together so that I get 1. So the number that I want, the power that I want to use here, is actually going to be the reciprocal power. So 3/1. So that means if I take this side to the 3/1 power, I have to take this side to the 3/1 power. And here's what happens. I have x to the 1/3 times 3/1. So as I multiply those, the numerator cancels with this denominator, and this denominator cancels with this numerator, and I'm left with just 1 as my exponent. So I have x to the first equals 4 cubed. 3/1 is the same as 3. So I get x to the first, or plain old x, equals 64. Now, just like above, I need to plug my solution in to my original equation to make sure that it's a real solution and not an extraneous solution. So that means I have 64 to the 1/3 power minus 4 equals 0. 64 to the 1/3 power is the same thing as the cube root of 64. So if it helps you simplify by rewriting, you can do that. The cube root of 64 is 4. 4 minus 4 does give me 0. So this is a real solution. And then we do the same thing with part B. So for part B, this time I've got 2 times that thing with the rational exponent. So I'm going to divide both sides by 2. That would give me x to the 2/3 power equals 250 divided by 2 is 125. And now I want this exponent to reduce to 1. So I'm going to use the power rule, and I'm going to raise each side to the reciprocal power. So I've got 2/3 right now. I'm going to raise each side to the 3/2 power. Now when I multiply my exponents here, I have 2/3 times 3/2. So this 2 reduces with this 2, this 3 reduces with this 3, and I get x to the first equal to 125 to the 3/2 power. And I actually can't reduce 125 to the 3/2 power, so I'm just going to leave my solution like this and then check to make sure that it's not extraneous. So when I plug this back in, I would have 2 times 125 to the 3/2 power, then to the 2/3 power equals 250. So here when I multiply my exponents, I would have 125 to the 3/2 times 2/3. The 3's reduce and the 2's reduce. Again, that's why we use those reciprocal powers. So I have 2 times 125 equals 250, because again I would get just 125 to the first power from here. So 2 times 125 does give me 250, so I know again I have a real solution.